Okay, and the last thing that you'll need to know how to do other than graphing and converting the equation using completing the square is to start with some basic information and create the equation from just some basic information. So the first thing I always look for is the center, because once you know the center, you can frame out almost your entire equation, right? Because you know almost everything in this equation. You know h, you know k, you know equals to 1. The only thing you don't know are a squared and b squared. So my first part of my equation is just x minus 0 and y minus 0 squared. So I can just write x squared plus y squared equals 1. Now I need to figure out my a and my b values, or a squared and b squared, or which way they go. So if I can see where one of my foci or focuses is located, it will tell me if this is horizontal or vertical. So center is at 0, 0. The first focus is at 3, 0. So that tells me that I just walked horizontally. So this is going to be a horizontal ellipse. So I know that my a value is going to go under x squared. I currently know my C value, right? Because from the focus to the center is C. They tell me the total major axis length. So if the total major axis has a length of 10, that tells me that my A value must be 5. So A squared is what I'm putting under x squared. So that has to be 25. Then if I know A and C, I can use that Pythagorean identity to find B. A squared has to equal B squared plus C squared in an ellipse. So A squared is 25, B squared I don't know, and C squared, 3 squared would be 9. So this again looks like a Pythagorean triple, because when I subtract 9, I get that B squared is 16, so B is 4. I really care about the 16 in my equation though. So here's my finished equation for my ellipse. All right, so now let's see what different information they give us in example 4. They give me the center again. So I'm going to set up my equation the same way I did up here. X squared plus y squared equals 1. All right, so if my center is at 0, 0, and one of my vertices, it doesn't tell me major or minor, it just tells me one of my vertices is down 3. I can't tell if this is horizontal or vertical yet, but it tells me that the semi, so half of the minor axis, has a length of 2. Well, this has a length of 3, and that's half of this axis. So that tells me that in this direction, this must be the axis where half of it has a length of 2. So that tells me that B must be 2, so therefore A must be 3. And this is a vertical ellipse this time, because I went 3 in the vertical direction. 3 squared is 9, and 2 squared is 4. So my answer, x squared over 4 plus y squared over 9 equals 1. All right, this next example has a new word that you may or may not know, tangent. Tangent means, so if something is like tangent to a circle, let's say, that means it just touches the circle at one point and it does not go through the center of the circle. A secant line touches a circle or object at 2 points. So a tangent line just touches it at one point and it doesn't cut through. All right, so let's see what this circle looks like. Its center is at 3, 5. So there's the center of my circle. It's at, or ellipse, excuse me. It is tangent to both axes. So tangent means if I come over here, it's just touching at that one point and kind of bouncing off, touching at that one point and bouncing off. So if I flesh out this whole ellipse, kind of looks like that. Once I know the center, I can write the first part of my equation. Right 3 would be x minus 3 squared. Up 5 would be y minus 5 squared. And then I know it's equals 1. So now let's see, in the x direction, so horizontally I went 3. 3 squared is 9. In the vertical direction I went 5, and 5 squared is 25. So that looks like the equation of my ellipse. So now you're going to complete this back page on your own, trying completing the square and graphing the ellipse. And I'd also like you to try to plot the foci on those examples as well. And I'm available for help.